Hey everyone! Today we are going to be looking at multiplying rational expressions. Now, before we multiply rational expressions, let's multiply rational numbers. So let's look at number 1. We have 1/3 as a fraction multiplied by 2/7. The way we multiply rational numbers together is to multiply the numerators together, 1 times 2 over 3 times 7. Then we get our resulting answer as 2 over 21. Number 2, what we actually want to look at is factoring each numerator and denominator and then multiply. So let's notice that 24 can be broken up a couple of ways. We could either break it up into its prime factorization or think in terms of like factors with the 15. So I'm going to factor the denominator first. I get a 2 times a 3 times a 5. Looking for common factors with the 24, I'm going to rewrite the numerator as 1 times 3 times 8. Now notice that the 3's cancel here, and then 2 will cancel with the 8. But again, I want to get into the habit of thinking of our fractions canceling with common factors. So the 8 is equivalent to 2 times 4, and in the denominator, 2 times 5. That's why we are able to cancel those 2's. Before you may have said something like, oh, 2 goes into 8 4 times. That's all fine and dandy, but what happens when you're trying to simplify something like 15 under the 24? Instead of saying 15 goes into 24, you're actually looking for which common factors they have in order to cancel. So our final answer is 4/5. Now let's carry that same concept of multiplying rational numbers to multiplying rational expressions. Now let's notice in our property that for all rational expressions, a over b and c over d when multiplied is equivalent to multiplying those numerators together, a times c, over multiplying the denominators together. So let's do the same thing here, while at the same time factoring. So I have a 3 r squared s cubed times 4 times 5 t squared all over 5 times t to the 4th times 3 times 3 times r cubed times s. Now what we did is factor the 20 and the 9 so that I can clearly see the common factors that will cancel. The 3's cancel, the 5's cancel, and we have multiple factors of r that can cancel. I have r squared in the numerator and r to the 3rd in the denominator. Now we can factor r cubed in the denominator as r to the 2nd times r to the 1, or we can use our exponent properties. When dividing like bases, we subtract the exponents. So that's what we'll do in this case. I'm going to write this as r to the 1 in the denominator, and look at the s factors. Let me highlight those. I have s cubed on top, s on the bottom. Again, when I simplify that, I'm going to get s squared on top. Again, that's because s to the 1 is in the bottom, s cubed on top. 3 minus 1 gets me 2. Then let's look at the t factors. I have, again, let me highlight that. I have t squared on top, t to the 4th in the denominator. So that means I have t squared in the denominator. So what we need to do is make sure that we carry down any factors in the correct placement. So what we need to do now is scan across our numerator and see what factors we were left over with. It looks like we have a 4. Let me copy that here. And an s squared. I'll copy that right here. All over, scanning across the denominator, I end up with a 3rt squared. I don't have any common factors in the numerator or the denominator. So this is our simplified answer. 4s squared over 3rt squared. Let's consider example 4. Now we have polynomial numerators and exponents to multiply and factor. So let's tackle this first polynomial, the 3m cubed minus 3m. So what we're going to do here is take out a common factor of a 3m, and we're left with m squared minus 1 on the inside. Then I'm going to multiply that to 4m to the 5th. So what I'm doing is factoring each numerator in addition to multiplying. Let's do the same in the denominator. 6m to the 4th, that's as good as we're going to get. So I have 6m to the 4th times the entire binomial m plus 1. So let's wrap parentheses around that m plus 1. Now at this point in time, we can cancel common factors that we can recognize. So we should see that the 3 can cancel into the 6, since 3 goes into 6 2 times. And I'm left with the 2 underneath. And then at this point in time, we may see that the 2 goes into 4. This is one method we can do instead of having to break everything down to its exact prime factorization. So what I'm left with is a 2 in the numerator. Now let's look at our variables. I have an m right here and an m to the 4th right here, in addition to an m to the 5th on top. So I'm going to cancel my m with the m to the 4th, and now write m to the 3rd in the denominator. And then I recognize still that I have my m to the 5th on top. So let's cancel. I have m to the 3rd, m to the 5th. Since the 5 was bigger, I know I'm left with m to the 2 on top. So it appears as though we've factored as much as we can for this intermediate step. So let's carry down everything that we're left over with in the next step, in addition to factoring again. It appears as though I can factor my m squared minus 1, since that represents the sum of the difference of 2 squares. So let's factor that. We have m plus 1 times m minus 1 as a result of factoring the m squared minus 1. Then we're left over with a 2 in addition to the m squared. Do not forget those. So I'll carry that down here. And I'm also left over with an m plus 1 in the denominator. Again, I want to leave parentheses around any binomial or polynomial factors so that I can recognize those as things that can be canceled. So let's notice I have an m plus 1 in the numerator to cancel with my m plus 1 in the denominator. What am I left over with overall? The m minus 1 times 2 times m squared. So typically we'll write our answer with the numerical factor first as the coefficient. So my final answer is 2m squared times m minus 1. Let's look at this next example. I have polynomials in both numerators and polynomials in both denominators. So what we want to do is factor. Let's take out a common factor from the first numerator. The common factor is a c. When I take that out, I'm left with the binomial c minus 3. Now let's look at the trinomial c squared plus 4c minus 5. We want to factor this by remembering our factoring skills that we've been doing. We're going to make two sets of parentheses. The only way of factoring c squared is c and c. Then factors of 5 whose difference is 4. Well, the only way of factoring 5 is a 1 and a 5, so we'll place those in these two slots, and then place the negative in front of the 1 because we want to have a positive 4 value as a result of combining the outer product with the inner product. Next, let's write all of this factorization in the numerator since we're multiplying. Now in the denominator, let's factor next my c squared minus 25. Remember, this represents the difference of two squares. The pattern for factoring the difference of two squares is c and c in the front slots, the square root of the last term, the square root of 25 is 5, here and here, and then the sign pattern is plus minus. So now we're done factoring c squared minus 25. Now let's factor c squared minus 4c plus 3. What we want to do here is set up another set of two parentheses, place c in my front slots, and then factors of 3 whose sum is negative 4. Well, the only way of factoring 3 is a 3 and a 1, and we're looking for a sum of negative 4. So if I place my negative here and here, we end up with a sum of negative 4 in addition to a product of positive 3. Now that the entire numerators are factored and the entire denominators are factored, let's cancel common factors. So we get the c minus 3 over here to cancel with this c minus 3, this c minus 1 to cancel with this c minus 1, and then this c plus 5 to cancel with this c plus 5. So what are we left over with overall? Carefully scanning across your numerator, we get a c. Carefully scanning across the denominator, I have a c minus 5. And we're good to go. That's our final answer. And please do not be tempted to cancel the c's. Now that we have seen examples of multiplying rational numbers and multiplying rational expressions, this concludes our lesson.
Made with Doodlecast Pro.